Now, I will show you another one. These cases could be a lot more complicated, but for simplicity I will use something similar to what I had earlier. Let us say you are given this whole circuit and you are asked to find the Thevenin equivalent between the terminals A, B. That is, we need to find the Thevenin voltage and the Thevenin resistance between A and B, and that also can be done in terms of the 2 port parameters. Okay. So, in this case let me assume that the 2 port is described by Z parameters instead of Y parameters. Okay. So, what will I have? I will have this V 1, I 1, V 2, I 2, and I know that V 1 is Z 11 I 1 plus Z 12 I 2, V 2 is Z 21 I 1 plus Z 22 I 2. Okay. Now, I need to find the Thevenin voltage, that is, I do not connect anything between A and B, I have an open circuit and find V 2. Okay. Now, in this particular circuit, if we have an open circuit between A and B, I 2 will be 0. Now, this is not necessarily always the case. Okay. This is the case in this particular example. Okay. So, for VTH calculation, in this circuit I 2 happens to be 0, that may not always be the case. For instance, we could have some load connected here, in which case I 2 will not be 0. Okay. So, V 2 will be simply Z 21 times I 1, and that is VTH, right, the open circuit voltage that appears here. Now, what is I 1? That we can find out from this side. We know that V s minus V 1 divided by R s is I 1. Okay. And also we know that V 1 is Z 11 I 1, because I 2 is 0. Okay. So, putting these two things together, we will get I 1 to be okay, V s by R s times 1 by 1 plus Z 11 by R s. Okay. So, this is what comes out of the calculation, and V 2 will be simply Z 21 times this value. So, it is V s times Z 21 divided by R s plus Z 11. Okay. So, in this particular case it happens to be V s times Z 21 by R s plus Z 11. Now, we also have to find the Thevenin resistance. For that, we set the independent source V s to 0, we have R s and we have to find the resistance looking back into this one. Okay. That is, for instance, this is V 2 and this is I 2. We can think of injecting either a voltage or a current source. This has nothing to do with what parameter set we choose, right. This is described by Z parameters, but I could apply a voltage source on this side. Okay. It is only for measuring the parameters that we apply a current source in case of Z parameters. So, let us say I do apply a current source, I test. Clearly, you see that I 2 is exactly equal to I test. So, what I need to find is the ratio of V 2 by I 2, that is the resistance looking back between the terminals A and B. Okay. I also have this V 1 and I 1 over there. Now, again we have V 1 is Z 11 I 1 plus Z 12 I 2 and V 2 is Z 21 I 1 plus Z 22 I 2. Now, because we have this resistance here, we have a relationship enforced between V 1 and I 1 by Ohm's law. So, V 1 is minus I 1 times R s. This is because of the direction of variables chosen. I 1 is flowing out this way, whereas V 1 is defined with this polarity. Okay. Remember, we need to find V 2 by I 2, that means we have to eliminate V 1 and I 1 from these two equations. Okay. So, if I substitute this, I will get minus I 1 R s is Z 11 I 1 plus Z 12 I 2, and from this I get I 1 to be minus Z 12 divided by Z 11 plus R s times I 2. Okay. And I will substitute it in the other equation. I will get V 2 to be Z 21 times I 1, which is minus Z 21 Z 12 by Z 11 plus R s times I 2 plus Z 22 times I 2. And the Thevenin resistance, which is nothing but V 2 by I 2. I 2 is the same as I test, and V 2 is the voltage developed wherever you apply I test. This will come out to be Z 22 minus Z 21 Z 12 divided by Z 11 plus R s. Okay. So, that is what we are going to have. So, this whole thing, and it could even be a lot more complicated than this, is equivalent to a Thevenin source in series with a Thevenin resistance, where the Thevenin voltage source is given by V s times Z 21 by R s plus Z 11. You see that it is dependent on this network as well as the voltage source and resistance connected to it, and RTH is Z 22 minus Z 21 Z 12 divided by Z 11 plus R s. Okay. So, you can have a 2 port and some circuit using the 2 port, and the whole thing can be represented as by its Thevenin equivalent circuit. So, there are many more calculations you can do. The principle is always the same. You use the 2 port parameters and the relationship implied by them. That is, you have the voltages and currents of the 2 port, and you have some relationships between the voltages and currents. And also the circuitry that you connect outside of the 2 port will impose some relationship between some of these variables. By solving for all of these equations and eliminating some variables, you can find whatever you want. Okay.